Let's see. All right, so today we are going to look at complex numbers, which in essence are imaginary numbers. All right. Here's what we're going to look at. We're going to use the imaginary unit I to write complex numbers, add, subtract, and multiply with complex numbers, which these calculators will help us do. We'll sort of show you how to do it by hand, but also the calculator is going to be real easy to do. Use complex conjugates to write the quotient of two complex numbers in standard form and find complex solutions. So we'll use all this to solve equations. We've been finding zeros, but we've only found real zeros, which is points where it crosses the x-axis or touches the x-axis. But there are sometimes imaginary zeros, which are points on the graph that don't cross the x-axis. So that's what we'll look at doing there. All right, so the imaginary unit I, y'all should have talked about this in integrated 3, I do believe. Okay, some quadratic equations have no real solutions. If it's like a parabola that is, if you have a parabola that's like this right here, it still comes from a quadratic. There's still two solutions, but you notice that parabola is above the x-axis. It never crosses the x-axis. So this is a parabola that's going to have imaginary solutions. It would have two imaginary solutions. It comes from a quadratic. Quadratics have two solutions. All right. The reason it has no real solution is because there's no real number that can be squared to produce -1, right? If we were to solve x squared plus 1 equals 0, I would subtract 1 and I would get x squared equals -1. And then we know there's no real number we can square that would equal -1. That's where our imaginary and our complex numbers come into play. All right, so that's what it says. To overcome this deficiency, mathematicians created an expanded system of numbers using the imaginary unit I, defined as I is the square root of -1. All right, so the square root of a -1 is what equals that I. That's where we get an imaginary number whenever we take the square root. Yes? Oh, sorry. We good now? All right. Thank you. All right. So by adding real numbers to real multiples of this imaginary, you can obtain the set of complex numbers. All right. So everybody good on where we get the imaginary I? Square root of -1 is I. All right. Each complex number can be written in the standard form A plus BI. So now this complex number system, you'll see numbers that a single number that actually has two parts, an A plus a BI. For instance, the standard form of the complex number -9 minus 5 is -5 plus 3i, because if we have that square root of -9, what's really happening is we're breaking that down into the square root of -1 times 9, the square root of -1 times the square root of 9, and then we know that's the I, and we know the square root of 9 is 3. That's where we get 3i for that. Okay? So what we have is basically 3i minus 5, But what they tell us is the standard form. Nope. In standard form, they want to put the real part, right? In complex numbers, you'll have a real part and an imaginary part. Obviously, the imaginary part is the number that is multiplied by the I, all right? And to put it in standard form, they want the real part first and the imaginary part second. So we would write that as -5 plus 3i. And that's what it tells you right down there is the A is called the real part, the complex number A plus BI, and the BI, where the B is the real number, is called imaginary part of the complex number. All right. So you could have these complex numbers. You could have just like you could have 5i, that's a complex number. It just doesn't have a real part. All right. Or you could have a real part and an imaginary part to a single complex number. Both of those are single complex numbers. Obviously, if we just had the number 3, this is no longer a complex number because it doesn't have an imaginary part. For it to be in a complex number, it does have to have an imaginary part, or you're going to have to see the I in there somewhere. Real quick, while I'm thinking about it, on these calculators, the I button is above the decimal, the secondary part to the decimal. So if I hit second decimal, notice it will put the I on there for me. Okay. Sometimes too in mode, let's see if there is a, yeah, if you look down, if you're dealing with imaginary numbers a lot and you need to graph them or something like that, down here there is an A plus BI. That's where it's dealing with imaginary numbers. But I think with what we're doing today, it should, we should be able to leave it in the real. Yeah, it should. We should be able to leave it as the real. If we ever get to where we need to change it, I'll let you know. So let's go back to here. All right. So let's go to the next slide. Definition. Here's just the definition of a complex number. If A and B are real numbers, then the number A plus BI is a complex number and is said to be written in standard form. If B is equal to 0, then the number A plus BI equals A is a real number, right? If B is 0, then there means there is no imaginary part. That makes that I go to 0. So it is a real number. If B is not equal to the 0, then the number A plus BI is called an imaginary number. The number of the form BI, where B is not equal to 0, is called a pure imaginary number. So if it doesn't have the real part to it, all that's saying is it's called a pure imaginary number. 5i, -4i, whatever. Okay, it doesn't have the real part. When we're talking about sets of numbers, all right, real numbers and imaginary numbers are in complete sets or separate sets of numbers. It cannot be both real and imaginary at the same time. All right, but when you combine real numbers and imaginary numbers, that's where you get your complex numbers. Complex is a broader system. All right. This is true because every real number A can be written as a complex number using B equals I. So all real numbers and imaginaries are considered complex because if I had the number 7, I could write that as 7 plus 0i. Obviously, we never do that when we are just dealing with real numbers. Okay. But it is considered a complex number. 7 is considered a complex number because it can be written in that form. Okay. and I don't know why this is in here. It says two complex number a plus bi and c plus di written in standard form are equal to each other if and only if a equals c and b equals d. So for two, what's that saying is if I have -3 plus 4i, that is only going to be equal to -3 plus 4i. There's no other complex number that is going to be equivalent to. So that's sort of a theory that's sort of self-explanatory, or common sense theory, or a property. So let's go on. All right, operations with complex numbers: adding, subtracting, multiplying, dividing. Okay. To add or subtract two complex numbers, you add or subtract the real and imaginary parts of the numbers separately. It's kind of like dealing with variables. You add the real part to the real part, the imaginary part to the imaginary part. So if I had 3 minus 2i plus -4 minus 7i, all right, two imaginary numbers or two complex numbers, I simply combine the real parts. That's going to be 3 plus a -4, which would be -1. And then -2i plus a -7i is a -9i. All right. Just like if you were dealing, if you replaced it with an x, you would deal with that the same way. Real parts to real parts. Imaginary parts to imaginary parts. Make sure if I do have, let's say I have -4 plus 6i minus 3 minus 2i. All right, if I am subtracting, that negative does need to be distributed to both parts of that complex number. So that would become -4 plus 6i. And when I distribute that negative through there, that's going to be -3 plus 2i, right? And then -4 minus 3 is -7. 6i plus 2i is 8i. All right. The other thing, we have these calculators. If I want to add 6 minus 4i plus -8 minus 3i, right? That's going to be 6 plus a -8, which is going to be -2, and -4 plus a -3 is going to be -7i. When I hit enter, these calculators, oh, what happened? Let's see what I did wrong. Oh, that's a negative. That should be a negative instead of a minus. So there it goes. It goes ahead and completes that for you. All right. So this all becomes pretty simple once you have the calculator, but I do want you to understand what's going on without the calculator. But there shouldn't be any problems there with adding and subtracting. All that's saying is if you're subtracting a complex number, that you basically distribute that negative through there, right? That becomes -a minus bi. That's all they've done right there. And if you add the opposite, you're going to get 0. A plus bi plus the opposite of -a minus bi is going to be 0 plus 0i, which is 0. All right, I think we've got that. So here's just some examples. Here, you could punch all these in the calculator exactly as written. I'm going to do them by hand. 3 plus 2 is 5. And then -i plus 3i is going to be plus 2i, right? 1 minus 4, or I could look at distributing that, making that -4 minus 2i. So 1 minus 4 is going to be -3. 2i minus 2i is 0, so that becomes just negative 3. This one, I'm going to distribute this negative here, so this would become plus 2 minus 3i, and then that's going to be plus a negative 5 plus I. And so I just combine my real parts. 3 plus 2 minus 5 is 0. Negative 3i plus I is 8. So that just simplifies down to negative 2i. And then here, this one becomes minus 7 minus I. So I've got 3 plus 4 minus 7. That's going to be 7 minus 7 or 0. 2i minus I is 0. So this all simplifies down to 0. All right. So if you understand adding and subtracting with variables, which I'm sure most of y'all, or if not all of you do, really adding and subtracting with complex numbers is just the same. Okay, once we start multiplying, it becomes a little bit different, and I'll show you why. That's the examples. Many of the same properties of real numbers are valid for complex numbers. Associative property doesn't matter what order you multiply or divide. Commutative property, associative, it doesn't matter how you group them together before you add them or multiply them. Commutative, the order doesn't matter, and you still have a distributive property. I'm not really going to go through that. All right, so here's just an example of, let me see, did they say anything about I squared in here yet? Let's see what they do. Okay, we'll talk about that as we. Okay, so some multiplication, introducing with that, and this will bring in the one thing that is a little bit different than just a normal variable. 5 times that complex number, you just distribute that 5. That would become negative 10 plus what, 15i? Now, here's where it's going to get a little bit different. Now, if you multiply it out, it's the same. I'm going to distribute the 2, so I'm going to have 8, plus 6i, minus, then I got to distribute the minus I, so that's going to be minus 4i, and then minus 3i squared. Okay, now here's the difference. All right. And what I would do, what's still alike is I'm going to combine the 6 minus 4i. So that's going to become 8 plus 2i minus 3i squared. Now, here's the difference. I squared, which we know I is equal to the square root of negative 1, right? And if I were to square I, or square both sides, what happens when we square a square root? We lose the square root, right? So what does I squared equal? It equals negative 1, right? So I squared simplifies to negative 1. Anytime you have an I squared, that's the same thing as, or it's equal to negative 1, right? So what I have to do is down here, this is not simplified because that's negative 3 times what? That's really negative 3 times negative 1, right? Which is 3, positive 3, which means I have to combine that with the 8. So I end up with 11 plus 2i. All right, so what you have to be careful of is anytime you get an I squared, that I squared turns into a negative 1. You multiply it by the coefficient, and then you can combine it with whatever. Now, let me pull this up on the calculator, and the calculator does it for you. If I do the same problem on this calculator, so 2 minus I times 4 plus 3i if you'll notice, it goes ahead and does all that for you when we get 11 plus 2i. All right, so the calculator is very good at double checking our work if we're doing it by hand, or if you're just working with these. So let's look at this one now. Notice this one, 3 plus 2i, 3 minus 2i. All right, if you remember from factoring, that's the opposite of a difference of squares. When the terms are the same, except one's a plus, one's a minus, notice what happens. That's going to become 9 minus 2i. And then when I do that, that's going to be plus, I'm sorry, scratch that. 3 times 3 is 9. 3 times negative 2i is negative 6i. And then 2i times 3 is a positive 6i. And then 2i times a negative 2i is a negative 4i squared. Now, notice the 6i and negative 6i and plus 6i are going to add to 0. And then here I've got negative 4 times negative 1, which this is really 9 plus 4, which is 13. And if you'll notice what happened right there, because we're going to deal with this a little bit later when we talk about conjugates, whenever we had the same numbers in the complex number, except one's a plus, one's a minus, when I multiplied that out, it turns into a real number. Okay? It loses its imaginary part. All right, here, 4i distributes, so that would be negative 4i, and then that's going to be plus 20i squared, which we know I squared is a negative 1, so that's 20 times negative 1, so what I end up with is a negative 20 minus 4i. And then this one, whenever it has a complex number squared, we could write that out as 2 plus 2i, or 3 plus 2i times 3 plus 2i. And that's going to be 9, plus 6i. Notice what happens. This is just like this up here, except both of them are plus. When one was plus and minus, it's simplified down to a real number. If they're both plus or they're both minus, that doesn't happen because these middle terms do not add to 0. Plus 4i squared. Well, 4i squared is negative 4, so 9 plus negative 4 is 5, and then 6i plus 6i is 12i, so that's what we end up with. All right, so it is helpful to be able to do those by hand, although I'm sure most of the time you'll be getting help from your calculator and doing that, but that's sort of how we're stepping through when we do each of those. And the next few slides are just doing what we just did. All right, complex conjugates. Now, this goes back to what I was just talking about a minute ago. If we have the same complex number, except one has a plus in the middle, one has a minus in the middle. All right. If you notice that example that we were just talking about, the product of two complex numbers can be a real number. This occurs with pairs of complex numbers of the form a plus bi and a minus bi. Because what happens is that middle imaginary term always adds to 0. And then when I squared that of the imaginary part, that squares the I, which turns it into negative 1, which basically eliminates the I out of that part too. So whenever I have conjugates of imaginary numbers, same parts, except one's a plus, and that should be a minus right here. That's a misprint. That should be a minus. Or one of them should be a minus. It doesn't matter which one. So make sure you make that note. Don't get confused by that. The answer is essentially a squared plus b squared is what you end up getting. And that's because the b squared turns into b squared times negative 1. All right. So if it's asking for a conjugate, multiply each complex number by its complex conjugate. If we have 1 plus I, its conjugate is 1 minus I. The conjugate of 3 minus 5I is 3 plus 5I. All right, so easy enough. That's a conjugate. A complex number conjugate is it's the same number, you just change the sign in the middle. Okay, notice when I multiply that out, that's going to be 1 minus I plus I minus I squared. And that adds to 0. That turns to positive 1, and I get 1 plus 1 is 2. Here we get 3 times 3 is 9 plus 15I minus 15I. And then that's going to be minus 25I squared. That last term is always minus the start. Then when I square it, square the I, that becomes negative 1. It changes it to a plus. So that's what they're talking about. You just square the first term plus the square of the second coefficient. And this is where I end up with 9 plus 25, which is what, 34? All right, now, where they use the conjugates, let's see if we get to that, is when we're dealing with complex fractions. All right, it's kind of like square roots. You cannot have a square root in the denominator of a fraction. Notice to be in standard form here, you cannot have a imaginary part in the denominator of a fraction. All right, so if you got an I in the denominator, they don't consider it simplified. All right, so the way we get rid of the I in the denominator is we simply multiply the top and the bottom by the conjugate. Because when we take the bottom and multiply by the conjugate, right, that gets rid of the I. So let's look at an example here. And I'm going to shrink that down and do it, write it over here. 2 plus 3i over 4 minus 2i. 3 plus 2i over I can't read that. 3i. 2 plus 3i over 4 minus 2i. All right, so there's that complex number we're dividing. The problem is that's not simplified because there's an I in the denominator. Okay? So what I have to do is, right, it's just like with rationalizing the denominator with square roots. If I multiply the top and the bottom by the exact same thing, that simplifies to 1. When I multiply by 1, I don't change the value. So what I'm going to do is I'm going to multiply the top and bottom by the conjugate of the denominator. Okay, that simplifies to 1 right here, which means I'm multiplying that by the value of 1, which doesn't change the value. It changes the way it looks, but it doesn't change the value. So I'm going to multiply that out, right? I'm multiplying. All right, 2 plus 3i, so that's going to be 2 times 4 is 8. 2 times 2i is 4i. 3i times 4 is 12i. And then 3i plus 2i is 6i squared over, that's going to be 16 plus 8i minus 8i minus 4i squared. So let's finish simplifying. This right here, 6i squared is negative 6. So 8 plus a negative 6 is 2. And then 4i plus 12i is 16i over 8i minus 8i goes to 0. That becomes a positive 4 whenever we take the I squared to negative 1. So 16 plus 4 is 20. Now, the last thing we have to do is we do have to simplify the fraction. If you look at 2, the coefficient or the coefficient of the imaginary part, the 16 and 20. Everybody see 2 will go into 2, 16 and 20. So this fraction will reduce by a factor of 2. So 2 will go into 2 once. It'll go into 16 8 times. And it'll go into 20 10 times. All right. Now, if you'll notice over here, this is one way to write your answer. You can also, and you'll see this a lot with imaginary numbers, is you can split that up and make that, if we'll carry on up here, 1 over 10 plus 8i over 10. And then notice the 8 over 10 will simplify again. So you can separate that into I guess this is more correct as far as imaginary or complex numbers, because 1/10 is the real part. And now that simplifies to 4i over 5 is the imaginary part. So really, when we're dealing with complex numbers, it's better to go ahead and separate them. And I could have done that right there, 2 over 20 plus 16 over 20, and just simplified it once. All right. Now, I think when we put it in the calculator, it may give you this answer right here. Let's look. I'm going to put this exact same thing in the calculator. 2 plus 3i over 4 minus 2i. And let's see what the calculator gives us. That way you might need to be able to make an adjustment, because I'm not sure exactly how WebAssign wants you to put your answer. So if I've got a fraction, in the numerator I have 2 plus 3i. In the denominator I've got 4 minus 2i. Let's see what happens here. I hit enter. Yep, nope, it goes ahead and separates it into its real part and imaginary part. So that's good. That's how we're going to want to put our answer, as separate fractions, because that's standard form, real part and imaginary part. Okay. Now, once again, there our calculator does all that work for us that we did with that conjugate. So obviously, it is easier, instead of doing all that, is to be able to punch it into a calculator. Any questions there? All right. Now, when we're talking about solutions to quadratic equations, all right, so this is where we got to bring in the imaginary part when we are solving an equation. So here's just a reminder right here. If we have the square root of -3, okay, what that simplifies to is we cannot leave the negative inside the square root. We do have to say that's 3 times the square root of 3 times -1, which we know the square root of -1 is the imaginary. So this right here simplifies to the square root of 3i. Okay? We don't want to leave a negative inside the square root. Anytime there's a negative inside the square root, to simplify it, you're going to have to bring an I to the outside, because the square root of that negative is I. Just like we don't want to leave the square root of 4 in a square root. We got to simplify it out. That's called the principal square root. So the square root of a negative number is that square root of that number I. That's called the principal square root. All right. So here they're just working through some things. -3 times the square root of -3 times the square root of -12. I think this is the one thing this calculator does not do. It does not simplify square roots. So you do have to be able to simplify some square roots. Notice that is 3i times the square root of 12i. 3 times 12 is 36. Well, when we multiply that together, that's going to be square root of 3 times square root of 12, which is square root of 36. I times I is I squared, which is -1. And this simplifies down to -6. This is where you have to be careful. Let me double check, see what it gets on the calculator when we do this. Square root. Now, I think if we are dealing with square roots, I do have to change the mode of the calculator if we are going to deal with a negative square root, because then it's going to say it's a non-real answer. So I'm going to change that to deal with this square root. So that was the square root of -3 times square root. I'm going to be interested to see if they do make this. Yep, -6. Okay. So if you are going to multiply with square roots that are negative on your calculator, you do have to change that mode. But here's what we've got to be careful of, because most of the time when we've dealt with square roots in the past, we would have just said multiplied these two numbers together. But if I multiply negative 3 times negative 12, I would get a positive 36, which the square root of that is 6. So you've got to be careful to go ahead and take the negative, the negative out of the square root before we combine them. All right, if that makes sense. All right, so right here, square root of negative 48 minus the square root of negative 27. Well, the square root of 48, when we're simplifying it, I know that negative is going to become an I, right? This is really negative 1. And then 48 is 12 times 4. It's going to be 16 times 3 is 16 times 3. You got to simplify out your square root perfect square. So 16 is a perfect square, which is 4. Square root of negative 1 is I, and then I'm left with that square root of 3 on the inside, minus, and then square root of negative 27, that's negative 1, and then 27 is 9 times 3. Right? We got to simplify out any perfect square factors of the number, and that becomes minus 3. Square root of 9 is 3. The square root of negative 1 is I. Square root of 3. Now that they both have the same square roots, all right, I can subtract their coefficients. 4i minus 3i is I. And then I still have the square root of 3, and then the proper way to write it is with the I after the square root of 3. All right. Then the last one is just more of the same. We can look at it here. I'm squaring this, so it's going to be negative 1 times negative 1, which is 1. It's going to be negative 1 times the square root of negative 3, which would be square root of 3i. So negative 1 times 3i. And then we get the same thing when I say this one times this one. So negative 1 times negative 1 is positive 1. Negative 1 times 3i, square root of 3i is negative square root of 3i. That's going to be negative square root of 3i. So when I add them, I get negative 2 square root of 3i. And then 3i times 3i is going to be, or the square root of 3i times the square root of 3i is going to be 3i squared, which is negative 3. And then when that all simplifies down, it's right there. Of course, right here, this might be one you want to just punch in your calculator. Well, I don't know if that's going to work. Let's see if that even works. We might be careful. Wait, what was that? Because these calculators do not simplify square roots. So we got negative 1 plus the square root of negative 3 squared. I may need to go over this one again. Let's see. I think this might give us a decimal, which is not what we want, because these calculators do not simplify square roots. And then I'm going to square that. Yeah, you see how the calculator will not leave it in square root form. It puts that big decimal, which is not what we want. So let's go back to that problem, because you may see one like that on your assignment. Let's step back through that. That is negative 1 plus square root of negative 3 squared. So first thing I've got to do is simplify, take out that I, the negative, out of the square root. So that's really going to be negative 1 plus square root of 3i. And then since that is squared, I'm going to multiply that by square root of 3i. So this one, our calculator is not going to help us on. So now I distribute. Negative 1 times negative 1 is 1. Negative 1 times the square root of 3i is negative square root of 3i. Square root of 3i times negative 1 is negative square root of 3i. And then the square root of 3 times the square root of 3 is 3, and I times I is I squared. All right. Then this 3i squared turns into negative 3, so 1 minus 3 is negative 2. And then here, this is a negative square root of 3i minus square root of 3i. Well, negative 1 minus 1 is minus 2. And then the square root of 3i stays the same. So that's what's actually going on there. All right, so be careful right there. That gets a little bit confusing, right? These square roots that don't have a number up front has an understood 1 out front. So 1 minus 1 is where this 2 comes from. All right. So that's just taking some complex numbers and writing them in standard form. All right, so here's where we get into actually solving. So if we have x squared plus 4 equals 0, okay, we're going to isolate the x. We subtract 4 from both sides, and I get x squared equals negative 4. I take the square root of both sides. So what I have is the square root of x squared is x, and then I have the square root of negative 4, all right, which we know square root of 4 is 2, and the square root of the negative is I. Now, you do have to be careful with this. Whenever we take the square root within an equation we are solving, you have to include both the positive and that negative value. That's where they get the plus or minus 2i. Whenever I take the square root within an equation, now if it just asks me what's the square root of negative 4, it's asking for the principal square root, which is the positive root. All right, but if you're solving an equation to where you have to take square roots of both sides of the equation, you've got to include both the positive and the negative of that square root. And that's where they get the answer plus or minus the square root of 2i. All right. So just remember that whenever you have to where you can isolate the x squared, you take the square root, you got to include both the positive and the negative. All right, and then they have an example there of using the quadratic formula. So if we have 3x squared minus 2x plus 5 equals 0, obviously if it's going to lead to an imaginary number, all right, we cannot factor it, so this will not factor. So let me rewrite this down. We've got 3x squared minus 2x plus 5 equals 0. All right, it will not factor. So we're going to use our quadratic formula. And if you remember what it is negative b plus or minus b squared minus 4ac over 2a. So what we get, that's b is negative 2. So that means that's 2 plus or minus negative 2 squared minus 4 times 3 times 5, and then 2 times 3. All right, now we can't just punch that in our calculator because if we're looking for an exact answer, we want to leave our answer in square root form. These calculators are going to change these to decimals. So we do have to be able to simplify and simplify this down. So that's going to be 2 plus or minus. Now we can put this in the calculator, negative 2 squared. Make sure you put the negative 2 in parentheses. Minus 4 times 3 times 5. I get a negative 56 over 6. So if we were just dealing with real numbers, we'd say this does not exist. But we are now dealing in complex numbers. And so we've got to simplify this square root of 56. And I have to see if 56 has any perfect square factors. So will 4 go into 56? I think it will. 56 divided by 4 is 14. So what's happening here is we've got 2 plus or minus square root. That's going to be -1. And then 56 will break down to 4 times 14. So you got to remember how to simplify square roots. Over 6. And so that's going to be 2 plus or minus. The square root of 4 is 2. The square root of -1 is I. And then we're going to be left with the square root of 14 over 6. And then to get this into standard, I'm going to go back up here. I need to split that up. So that's going to be 2 over 6 plus or minus 2I square root of 14 over 6. And then that will simplify to 1/3 plus or minus I square root of 14 over 3. And in the book, they're showing you square root of 14I, but it really doesn't matter. I typically put the I out front just because it doesn't look like that I gets caught up underneath the square root. And let's see if that's what they ended up with. Yeah, you see how they wrote that? This is another way you can write it. You can write the I out by the fraction bar. We'll see once we get into the WebAssign how they want their answers written. But that's just simplifying, and I believe that's it, simplifying the complex number. So that's a big part of this lesson is just simplifying complex numbers, which is easy if it doesn't have a square root. We can use our calculator, but once there's a square root in there, then our calculator is not quite as helpful. Now let me see if I can figure out how to